brings up chapter 5, and I'm probably just going to be able to touch on this. And I'm thinking I'm going to probably have to do some little videos here to extend on out into this for probability, a basis for probability. When we're talking about probability and we're talking about statistics, we're talking about the very basic foundation of randomness. Randomness. Let's try some randomness on my data sheet here. Randomness. All right. I'm gonna spin my pen, and randomness directs us to R, right? So that's what randomness directed us to, right? This is randomness, spinning a dial or rolling a dice. Now it's going to R2, right? Now we've got that. So that's randomness from the universe. We're going to use randomness from technology. All right, momentarily I'm going to proceed with number 61, which is 5.1.2, which is like an old school way of seeding and randomizing a sample. But like I was saying, we're going to use technology. So just as an introductory thing here, let's zoom in, and I will show you the steps to go just a little bit less than old school, where you're doing it by hand. You're putting the names in the hat and you're shaking it up like you're randomizing it, right? You're doing the roulette table. You got the ball going round and round and round. All right, you're randomizing, letting the universe indicate your randomness. But we have technology that uses various procedures to come up with random numbers. So let me just start on the calculator. I have a TI-84 plus Python. Oh, nice one. A nice color. Although anyway, we'll find it. Anyway, let's randomize our number. What you would do, you would go down here to math, right? And then you can see these titles. And you'd scroll over here to probability, right? Probability, that is the topic of our class right now. The random integer. I would like to have seen how that worked, but hey, it's not worth it. Notice this random integer thing comes up. We want to put a lower limit here, 1, an upper limit out of 10, right? And then let's see what we have. And then there's our random number distribution. I wanted 10 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Between 1 and 8, notice it repeated. 1 repeated 3 times. And then I think that's the only repeat, but still, that's randomness. And luckily, we'll be drawing on technology, not the TI. But we will be using other technologies to find the random number. Right, so back to this problem here, ID 512. It says it's on page 40, but I believe it's actually 39. When we're working with these things, that's the numbering got weird. But anyway, this is going to be an example of what we were talking about randomizing a sample to ensure integrity. Randomness is this essence of any kind of statistical study. Without it, then you can throw your results out the window, right? What's the first thing everybody says whenever somebody publishes a survey that some people don't agree with? The first thing they say, well, they must have only interviewed this group. They didn't interview any real people, right? No. If they're a statistical company, they've got to be using randomness. Otherwise, I don't know. They're not a statistical company. They're just acting like one, right? Anyway, we want to carry out, as it says right here, carry out randomized experiment. Remember, I think that's the design experiment from the beginning, right? You had to randomize it, right? You had to randomize it, okay? So there is a difference in the amount of information remembered between students, either the ones who take notes using a computer versus those who wow, this one's like right up the old school alley, isn't it? But anyway, so it says we have 20 students, so that means n equals 20. That's the total number in the sample. All right. And we want each to have an equal chance of being assigned to the computer group. Is the computer group. And paper is the paper group. Paper and pencil handwritten notes, okay? See, we have a paper group. And then we have a computer group. Notice that we're looking at numbers between 1 and 10. And that means that the odd between one, notice it's also only one-digit numbers, right? Because when we look at our data set that we're going to be drawing from, it's set up in one-digit numbers unless we were given specific instructions to take groups of 3 or 2 or whatever. But we've got this many numbers for people, and it tells us to use these numbers. Notice that 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Notice we split it into 2 groups over 10, right? So that means we should be assigning half, theoretically, to the computer groups and half to the enrichers. Theoretically, right? But it's not always going to work out that way when we're conducting an experiment, doing something in real life, right? So now, let's write the sequence of numbers. Let's write the sequence of numbers. And notice where it says to start. Begin with the first digit, third row. So that is what we would call a seed. So a seed is like, you're going to let the computer start with this number. Then it's going to use that as a base to run its randomization program. Sometimes they use polynomials, or I've heard once that they base it on white noise. Also, it could be based upon last mouse movements. Maybe there's a whole list of things that they draw the seed from the universe and then put it into a randomizing system. I guess that's to keep it honest. Kind of like a placebo. We'll get to the placebo. Well, we talked about the placebo, right? It's a controlled group. So that we record what we seeded. So if there's anything wrong with the randomization, perhaps the first place to look would be the seed. So the seed is row 1, first column, or as it says, the first. As we can see, this is column 1, right? And then this is the third row. Seed row. I wrote row 1. It's actually row 3. There we go. See, it's the third row. That's where the seed's going to come in. So that's what we would do. We would go down here, and I'm just going to write them right here. And then I'll put them into the boxes. So we would have an 8. We would have a 5. We would have a tree. We'd have a 1. We'd have a tree. That's 5. So now we would go 4, 0, 9er, 1, 0. As you can see, I just drew from these right here. All right. Just pause a moment, and then I will. Hold on a second. There we go. Let me check my view. Let me know if I get in the way. Nobody's there. Let me know if I get in the way. I don't want to get way up this beautiful map. Anyway, we're going to take those numbers and we're going to code them up here. We're going to code them up here. So we got ocho, 5, tree, 1, tree, 4, 0, 9er, 1, 0. Okay, so we only did 10, right? We only did 10. We only did 10, so we've got to do 10 more because, remember, n is 20. That's how much we want to have, how many individuals we want to have in our sample. So I should have done that all to begin with, but notice now we're going to have ocho, 9er, tree, 7, 1, 1, 9er, ocho, 5, 0. There we go. Now we'll put that up here. We got a ocho, 9er, tree, 7, 1, 1, 9er, ocho, 5, and not. Just Robodine again. So let me just double check my numbers, make sure before I proceed if I did any transcribing errors or anything of that sort. 8, 5, 3, 1, 3, 4, 0, 9er, 1, 0, ocho, 9er, tree, 7, 1, 1, 9er, ocho, 5, 0. That's confirmed. That is confirmed. Now we will move on and we will translate these over to the letters. Remember what we had, right? These numbers are the paper group, and these numbers right here is the computer group. 1, tree, 5, 7, 9er. Let's double check that. I didn't put any notes. This language, so let even represent the computer. All right, yeah, I'm getting lost in the language. And the odd digits, the paper. The odd digits, pen and paper. Okay, there we go. I'm just further reading up here. That's the mess. That's the challenge. That's what slows me down is trying to read and understand what they're asking. So now, if we look, ocho falls into here, so it's a computer. 5 falls over here, so it's a paper. Tree falls over here, so it's paper. And as I go through these, I'm going to check these. I've got C, P, paper, and then there we are. We got odd it goes to paper. Then tree goes to paper, and 4 goes to computer. There we are. We got those coded. Now 0 is even, so evens go to computer. Then we have niner, which is odd, would be paper. 1 is odd. 0 is even. Ocho is even. Niner is odd. Tree is odd. 7 is odd. 1 is odd. 1 is odd. Niner is odd. Or computer. Paper. Computer. Let me double check. Computer, paper. Paper, paper. Paper, computer. Let me see, this is, there we go. Computer, paper. Paper. Computer, computer, paper, paper. Paper, paper, paper. Paper, computer, paper, computer. There we go. We have them assigned. Then it says what percentage out of the 20 were assigned to the computer group. So let's total up the computer groups. 1, 2, 3, 4, 5, 6. I got 6. Is that what we got? I think it's 7. 1, 2, 3, 4, 5, 6. So there is 7. And then there's there's 7 computers. And remember, and if we wanted to, we could go ahead and count up. We know the complement. By the way, that's a complement, right? The complement of computer, because you can't have both. Let me do it this way. 20 minus 7, that's the sample space minus the piece, or whatever we're going to call it. And see, we get a 13. This is a complement, so let's see. C complement equals P. Just a little from what we were getting into before. But anyway, to find this, we would take 7 over 10 times 100, which we should get, 7 over 20 times 100. I got 35%, but it wasn't working in my head. I had to readjust there and cheat just a little bit because my brain wasn't working on that one. All right, so now this is the other part, probably the most challenging part. But let's just break it down. Notice this says another way of random number. There's a lot of different ways we could have done this. Notice here it's assigning just the first 5 digits to the pen and paper, and then the last 5 digits to computer. Look at this one. This one should be the same. The only thing, notice what's different about this is it's got this 10. Remember, we're doing integers, not 2-digit numbers, 1-digit numbers. So that right there means that C will not work. Okay, we've identified a pattern. Here it is again. Here it is again. Here it is again. So that one will not work. That one will not work. So we know C and E are out. Now let's just look at these other two. Notice all this does is make odd digits go to computer. Before, right, we had even going to computer. So all they're doing is switching this around. Even go to the paper, right? So both of those would work. Those would be fine. Okay. Switching the groups around. Notice this one is it's going to have the first digit go to the computer group. This is very similar. Only notice it has the first 5 digits going to the paper. This one is going to the computer. These digits, which this one up here had going to the computer, are now going to the paper. So that's fine. That works. So it would be those, oops, it would be those right there. Zoom out. I hope I didn't, I lost track of what my